Okay, so today we got the problem 152 maximum product subarray, medium problem. We're supposed to find the largest, so subarray with largest product, which fits into 32-bit integer for any subarray, which is great because we can do prefix. Products. Now, the trick here is that, okay, so let's say we try to find for a given position the largest, so subarray starting there with largest product. Well, if we meet 0, right, then all rest of subarrays will have a 0, and so we split it into two cases. First, if we have a 0, the initial answer is 0. Then we split the array into non-zero subarrays, right? So we just cut out zeros and then we are left with some subarrays. So here we would have just one, here we would have these two, right? And then for each of them, we try to, again, same approach for each starting position of subarray, find largest product. Now, how to do that? Well, notice then, since if we have even number of negatives, we get a positive sum. So at each position, what we try to do is that, okay, so let's say we are at first position, and we maximum sum we can get is here it's just 2, 3. But let's say we would have many negative numbers. So if there is even number of them, we take the entire array, because like not taking positive numbers doesn't make sense, and if we have even number of negatives, we should take them. Now, if there is odd number of negatives, we take everything up to before the last negative, right? Because taking it would produce a negative number, and anything else would just rest is positive, so that would decrease it even more. So for sure, taking this or this is smaller than taking this. Now, okay, what happens when we so if we see where the how many negative numbers are there and where is the last one, we can calculate this. Let's say we move, right? So for positive number, nothing changes. Suddenly we process a negative number. Well, if there was odd number of negatives, now suddenly, right, after we have, or let's say we have processed it, like, so we still care about the rest of the numbers. So how many is in the rest? And now if there is even number of negatives in the suffix we are considering, we take the suffix, and if not, then we go until the last element. And here this is like a special case with one element which is negative, but every other subarray which does not have a single negative number can be made positive. So I guess let's do that. So first we check if 0 in nums, ans, let's do nums 0, if 0 in nums, ans is 0. And now we are going to process the subarrays. So let's say we start for let's do like L is 0 and while this, and now if nums L 0, L plus equals 1 continue, right? And otherwise, if we don't have 0 there, then RL while R is N, so we don't get to the end, and it's not a 0 element, right? Then we increase. So we also give a negative index. If nums R is under 0, then a negative index is R, because we want to keep the last index. and we also want to keep the prefix whatever, prefix product. So let's do like 1, right, and prefix product, and here is what we are doing. So if R is L, then product of R is equal to nums of R, right? Else product of R minus 1 times nums R, right? So we're just calculating the prefix sum. And now that we have that, let's see, so negative index should be minus 1. And then, right, so we process the subarray, and now we want to do this. Oh, we need to have like parity, right? So negative count is 0, negative count is plus 1, right? And now while L is less than R, then we do this, right? So if negative count is odd, then we want to go, so that's the real R is negative index minus 1, right? Now if real R is less than L, which I guess should be the case if there is just a single negative number and we get to that number, I think. Yeah, so if real R is smaller than L, then we do real R is L, and then real R minus 1, and then we want to do like so original L is L, and now ans is max, ans product of real R times, divided by product of, and now it's product of L minus 1 if L over original L, else it's 1. And then L plus equals 1. And no, and then even count. No negative. So if nums L under 0, then negative count minus equals 1. Return answer, I guess something wrong, or original L. Okay, I mean it seems to work. Let's see. Okay, that's fair. I have a big constant factor, I think, which is why that happens, but and also this product is kind of oof. Maybe if I put it into 1, so product is this, no, but append is gonna be slow also, so if num 0 ans 0, maybe. Let's see. Yeah, that didn't really help. So maybe I'm doing too much. It's very likely I'm doing too much. Okay, so guess I can quickly write down the solution. Sliding window on. So if the subarray has, if the array has a 0, let's initialize the answer to 0, otherwise use nums 0. Initialize ans with num 0. Now we can chop the array into non-zero subarrays, i.e. subarrays with into non-overlapping subarrays without the zeros. The answer is gonna be maximum subarray product over all the new subarrays, over all the new arrays, since multiplying by 0, since extending subarrays from them in the original array would just multiply the answer by 0, which would then never change, and we have already stored 0 in ans answer if there is 1. Now we have now reduced the problem to subarrays to maximum product array, maximum subarray product on non-zero array. To solve that problem, we can find the maximum subarray maximum starting at each position in O1 amortized approach. If the subarray, we go through the positions in non-zero array from left to right and keep the count of negative numbers in the suffix. if the count is even, we take the answer, the largest, the best thing to do is to extend the subarray until the end. Since multiplying even number of negative numbers results, since the product of even number of negative numbers is positive. Otherwise, we want to extend the subarray until just before the last negative number. This way we know, we calculate the number of negative, the total number of negative numbers in the array and the position of the last one. We know the subarray coordinates we can calculate this subarray, the maximum product subarray coordinates for a given L. Ending position in O1, and if we pre-calculated the prefix products in that array, we can also calculate the subarray product in O1. Note that we can use prefix products in subarrays since their values, since maximum subarray product, since the answer fits into a 32-bit integer. Okay, so time complexity ON, since where n is the size of the original array, since we first chop it into, since we solve each chopped subarray independently into linear passes. First, to calculate the prefix products, number of negative numbers and the index of the last negative number, and the second pass to the actual subarray products, and that's ON, since in worst case we have to store prefix products for the entire original array. Okay, so that's it for today. Classic Simple trick. See you tomorrow.